Welcome everyone back to my channel. Today we are going to do Kuta Software Calculus Higher Order Derivatives. First, let's review some rules. Rule number 1. If y is a constant, then its derivative is 0. Number 2. If y is a constant times x, its derivative is just that constant. Rule number 3. If y is a constant times x to some power, then its derivative is that constant times the power x, and then you reduce the power by 1. In number 1, d2y over dx squared simply means deriving twice. So first derivative dy over dx, we will use rule number 3. There is an invisible 1 here. So multiplying the constant and the power, -1 times 2 is -2. X, reduce your power by 1, and it's just 1, which we don't have to write. Then d2y over dx squared is simply deriving the first derivative. So now we use rule number 2. Since it's just a constant times x, the derivative is just the constant. Let's practice number 3. d3y over dx cubed simply means deriving 3 times. First derivative, let's call it y prime. Use rule number 2, it's just the constant -4. Second derivative, use rule number 1. Derivative of a constant is just 0. Third derivative, you can say y3 prime, or it's equivalent to saying d3y over dx cubed. Well, we're deriving the second derivative, and derivative of 0 is still 0. Let's try number 4. So first derivative is just f prime x. We'll use rule number 3 where you multiply constant and exponent. That's 20x. Reduce the power by 1, it's 3. Second derivative, multiply 20 and 3, that's 60x. Reduce the 3 by 1. Now third derivative, multiply 60 and 2, so it's 120. X, reduce the 2 by 1, and we are done. In number 5, d4y over dx to the 4th simply means doing it 4 times. Let's practice on number 6. So first derivative y prime. Using rule number 3, multiply, that would be 15x. Reduce the 5 by 1, it's 4. Now treat the second term separately. Deriving that using rule number 2, it would just be your constant -2. Now second derivative, you would derive first derivative. Using the third rule, derive the first term. 15 times 4, that's 60x to the third, because you reduce the 4 by 1. And derive -2 would be 0, because -2 is a constant. Third derivative, which is equivalent to d3y over dx cubed. Use rule number 3. Multiply 60 and 3. That's 180. Reduce your 3 by 1. Let's try number 8. I see a radical in there, so we should rewrite it first before deriving. So I'm just rewriting y without deriving. So copy -x squared plus the 2 is a coefficient. Now write the x in exponential form. It's always power over root. So 2 over 5. Ready to derive. First derivative, -1 times 2 is -2x. Reduce the 2 by 1, so it's just 1. Plus, we have to multiply the 2 and the 2/5. We'll do it on the side. 2 times 2/5. 2 is 2 over 1. Multiply across, you got 4 over 5. So 4 over 5 x to the power of 2/5 minus 1, which is the same as 5/5. So that's negative 3/5. Second derivative. Deriving your first term, use rule number 2. So derivative of that is negative 2. Now here I have to multiply these using rule number 3. So 4/5 times negative 3/5 is negative 12/25. So it's minus 12/25 x. I have to reduce the negative 3/5 by 1, which is 5/5. So negative 3 minus 5 is negative 8/5. I still have one more derivative, so I'll squeeze it in here. Third derivative is, well, derivative of negative 2, which is a constant, is 0, so I don't need to write that. But I do need to multiply this. This negative belongs to this coefficient, so I'm going to multiply it here. Negative 12/25 times negative 8/5. Nothing cancels, so I'm going to multiply across. So negative times negative is positive. 12 times 8 is 96. Over 25 times 5 is 125. So 96 over 125. X to the power. We're going to have to reduce the negative 8/5 by 1. So subtract 5/5. And that equals negative 13/5. Wow. I'm to the power of negative 13/5. Thank you for watching my video. Please leave a comment if you would like to see a video of another math topic.